So guys, the question that we will be discussing in this video is the next smaller number. First of all, I will explain you the question with the help of example. Then we'll move towards the approach of this question. And then finally, at the end, I will show you the code, how to write the code for this particular question. So now let's start this video. Okay. So first, moving with the question, the function accepts an integer array A of size m. Replace each number of the array with the nearest smaller number on its right in the array. Okay, assumption is that all integers present inside the array will be greater than 0. There is one note also, that is return null if array is null. So if array is empty, you will have to return null. Replace number with -1 if no number is present on its right. So let's just first read the question again and then see the example. The things will be much clearer to you. The function accepts an integer array A of size m. Replace each number of the array with the nearest smaller number on its right in the array. Let's just quickly now look at the example. The things will be clear. So this is our input array. Okay, this is an input array of length 8. So 3, 2, 11, 7, 6, 5, 6, 1 are the elements of the array. Now what we have to do, for every number we will have to find the nearest smaller number on the right. Again, I'm telling you, for each number, we have to find the nearest smaller number on the right side of that number. So let's just see. So if we will start from 3 here, so what will be the nearest smaller number to 3? That is the number that is less than 3 and it is nearest to it on the right side. So next number is 2. So 2 is less than 3, so answer will be 2, and 2 is the nearest one to the 3. Next is 2. So what number is less than 2 and it is nearest to 2 on its right side? So next number is 11. So it is not smaller than 2. Next is 7. It is not smaller than 2. Next is 6. Not smaller than 2. Similarly, this 6 not smaller than 2. And similarly, this 1. So here 1 is the nearest smaller number on the right side of 2, which is less than 2. So answer will be 1 here, because 1 is the next smaller number to 2. Next question, example is 11. So nearest number that is less than 11 is 7. So we will stop here only and we will not move ahead. So once you have found a smaller number nearest to 11, nearest to the current number, we will stop there only and we will simply output that and we will not move any forward. Next is 7. So again, smaller than 7 is 6. So we have done 6 here. Next is 6. Again, smaller than 6 is 5, and we will not move ahead and we will just write it here. So we will have to find the nearest smaller number on the right side of the element. So next is 5. What is the nearest smaller number that is less than 5? It is next is 6. So 6 is greater than 5. Next is 1. It is less than 5. So again, the next smaller number on the right side of 5 that is smaller than 5 is 1. Again 6. We will move towards the right side and you will find that the number that is smaller than 6, it is 1. So again 1. And now we are on the 1. So next smaller number that is smaller than 1 and it is nearest to 1 on the right side is no number. So if no such number is present, then the answer will be -1. Okay, then the answer will be -1. Simple. Now let me just change this input and the things will become more crystal clear to you. 1, first number is 1, then 2, then 3. Okay, so 7. So again, for the last number, there is no such smaller number every time. For every test case, for the last number, answer will be -1. So again, we will be starting from first number. Let's just see. So for the next smaller number to 1 on the right side, if you will clearly see, it is nothing. So if there is no number present, we will give -1. Next smaller number on the right side of 2, less than 2, nothing. We will give -1. Next smaller number than 3 on the right side, there is nothing. Again, we will give -1. Similarly with -4. Similarly with -1 here. Similarly with 5 also. Similarly with 6, as there are no smaller numbers that are present to the right side of the current number. -1, -1. So this was the entire question. I hope the question is clear to you. It is very simple. If we are on the current number, we will have to find the nearest smaller number on the right side of the current number. So if there is no such number exists, then we will simply give -1. And for the last element of the array, the answer will always be -1, because there is no further elements on the right side of the last element. So I hope now the question is clear to you. Let's just quickly move towards the approach and then we will see how to write the code for this same. Okay, so guys, now let's see the approach of this question. So this is our input array 3, 2, 11, 7, 6, 5, 6, 1. And what we will do, we will use an extra we will use an extra space one, that is stack we will be using. So this one is our stack. Okay, let me just write it. So stack based approach we will be using. So this is our stack, and we know that stack is last in first out approach. Okay, next is the output array, because we will have to find the what we have to find, the next smaller number, and we will have to store it somewhere. Okay, so now what we will do, we will simply start iterating this input array from behind. So I have given the direction also. From behind we will start iterating the array, and for every element, what we will do, we will I will explain that once we will start doing the iteration one. So as I have told you earlier, for the last element the answer will always be -1, because there is no such element that is present on the right side of the last element. So this is our output array. So for the last element we will give it -1, and what we will do, and we will now push this last element into the stack. So we have pushed this last element into the stack. Okay, now for the role of this particular element is done. Next is 6. Now we have to find the next smaller number, nearest next smaller number to 6. So what we will do now, see, we have placed 1 in the stack. Now what we will do, we will compare this 6 value with the top of the stack. We will compare this 6 value with the top of the stack. So the current value is 6 and top of the stack value is 1. So if our current value is greater than the top of the stack, it means that on the top of the stack the next nearest smaller number to 6 is present. So what is present on the top of the stack? It is 1. So therefore the next smaller number to 6 will be 1. Now what we'll do, we will simply push 6 into it. Okay, so why we had done it, we have compared this 6 with the top of the stack, and if that current value, if the value of 6 is greater than the top of the stack, it means that the element that is present on the top of the stack is the next nearest number to that number. So we have done 1 here, and we have pushed 6 into the stack. Now moving ahead with the 5. Now we will again compare this 5 with the top of the stack. Okay, we will compare this 5 with the top of the stack. Now what we'll do, you can see that 5 is less than 6. 5 is less than 6. But what we'll do, we have to find the nearest smaller number to the right of this right of the 5. So 5 is less than 6. So it means that 6 is the top of the stack is not the smaller than the current element. So what we'll do, we will pop this element from the stack. Okay, next what we'll do, we will again compare this 5 with the top of the stack. Now we can see that our current element is greater than the top of the stack, that is 1. So it means the next nearest number to 5 is 1 only. So we have pushed 1 here, and now what we'll do, we'll push 5 into the stack. Now we are moving towards the next element, that is 6. So again we will first compare this 6 with the top of the stack. Now 6 is greater than 5, it means that the top of the stack is less than the current number, and if this is the case, then the top of the stack is the nearest smaller number on the right side. So here we will put the value of top of the stack as 5, and we will push 6 here. Okay, we will push 6 here. Now we are moving to 7. So again the current element is greater than the top of the stack, so it means the nearest smaller number to 7 is 6. So we will give 6 here, and we will push 7 here. Next is 11. So again the current number is greater than the top of the stack, so what we'll give, we will give top of the stack here, and we will push 11 here. Okay, next number is 2. Now comes the very important part. So next number is 2. We will again compare this number with the top of the stack. So is 2 greater than 11? The answer is no. 2 is not greater than 11. There it means that, see, remember one thing, the top of the stack should always be less than the current element. So is 2 greater than 11? The answer is no. So what we'll do, we will pop it. Now 2 is greater than 7, answer is no, we will pop it. Now 2 is greater than 6, answer is no, we will pop it. Now 2 is greater than 5, answer is no, we will pop it. Now is 2 greater than 1? The answer is yes. So it means that once we have found on the top of the stack that our element of the top of the stack is less than the current element, then that element on the top of the stack will be our next smaller number, that is 1 here. And now we'll push 2 here. Next we have found 3. So is current element greater than the top of the stack? The answer is yes. So we will, in this output array, we will move 2 here, that is top of the stack, and we will push 3 into it. Okay, so now our iteration is over, and in the output array we have our answer. So if you will look closely, it is the correct answer, 2176511. So it is 2176511 and minus 1 in the last. So this is the entire approach we have to follow. We will just have to compare the current element with the top of the stack till the current element is greater than the top of the stack. Till that we have to compare. Okay. So I hope now the approach is also clear to you. Now let's just quickly move towards the coding solution of this particular question. Okay, so guys, for saving time, I have already written the code. So in Accenture, you will just have to implement the function only. That is, your input will be given and what you have to return will be given. You just have to implement the function inside this particular block. Okay. So, but one thing you have to notice that as of now, for explaining purpose, I have taken the return type and the input as of my own, but it will change when you will go in actual exam. So the return type, you will have to look carefully that what is the return type and what you have to return from the function. So this particular function is just for explaining you how you have to write the logic. So do not like just blindly copy this code in your exam. Just make sure that you are checking what is the return type, what is the input type in this function, and then only copy those values. Okay, because the names can change, the data type can change, and the return type can also change. So don't just blindly copy this question in your exam. Just follow this logic and just do the return type as per your function is suggesting in the exam, not as per mine code here. Okay, so let's, having said that, let's move ahead. So as I've told you, we will be using the stack database, stack data structure. So this is the stack data structure. You have to declare stack, but again, for using this stack data structure, you will have to import this library, hash include this library. So in Accenture, you are allowed to include these libraries. Okay, so just include these libraries as well for using this stack data structure. Okay, so what we have done, initially the stack is empty. We have pushed the last element of the array in the stack, and we have in this array only we have made the update that last element will be -1. As I have told you, the element, next smaller element to the right of 1 will always be -1. So we have pushed first of all the last element to the stack, and then we have modified our current array only to -1. Okay, so here I am not forming any new array. I'm just modifying the current array only. So make sure to do this. Okay, next thing what we have done, we are iterating over the array from behind. As I've told you, we will be iterating over the array from behind towards the left side. Now for every element, this is int x is our current element. For every element, we will check the element that is present on the top of the stack. And as I have told you that when the top of the stack is greater than the current element, when the top of the stack is greater than the current element, we will pop that element, because that element will not be required. And till when we will do it? We will do it till the time our top of the stack is less than the current element. So again, I'm repeating, we will pop the elements from the stack till the time our top of the stack is greater than the current element. Till that time, we will continue to pop the elements, as I've told you in the approach section. If you have missed it, do watch that approach section also. Just rewind 2-3 minutes back. Okay, next we have our current element. Now once we have popped all the elements from the top of the stack which were greater than the current element, now once this while loop is over, it means either our stack will be empty, or the top element of the stack will be less than the current element. So if our stack is empty after this particular loop, it means that there is no element, no next smaller element that is present in the array on the right side of the current element. So we'll simply update our current element of ARR with -1. But if the stack is not empty after this while loop is over, it means that the top of the element of the stack is now less than the current element, that is x. So else in that case, what we'll do, we will put in s dot top. As I've told you, here we are putting s dot top. So, and later on, after this iteration is over, we will just push the current element also, that is s dot push x. We have just pushed the current element also in the stack. Like if we were doing like this, then we are pushing 6 also. Okay, as I've told you in the approach section. If you still have doubts, you can again go back to the video and look for it. Again, I'm explaining you just in simple terms. We will for the current element we will pop out the top elements from the stack till the stack is either empty or till the top element of the stack is less than the current element. And if our after popping these elements, if our stack is empty, we will it means that there is no next smaller element present for this current element, and we'll update the AR of I with -1. And else if the top of the stack is not empty and top, it means that after this loop the top of the stack element is the next smaller element for the current element. Okay, so we are just updating AR of I with s dot top, and again at the last we are pushing the current element in the stack. And once this for loop is over, you will have your entire output array in this ARR only, as I've done changes in the current array only and I have not formed any new array. So this was all the approach I wanted to discuss. But again, I'm telling you, remember to change the return type, data type as per your code. Just follow the logic from here, but do not blindly copy from here. Okay, so let's just now quickly run the test cases that I have shown you. So input value is 7. Then if these are the values 1 2 3 4 5 6 7, then our answer should be -1 for all the ones, all the cases. Because if you will look closely, there is no next smaller element present to the current element on the right side. So here all the elements should be -1. And if I just copy these values only, 3 2 11 7 6 5, let me just copy quickly. 3 2 11 7 6 5 6, then 1, and these are 8 elements. In this we will get our expected output as I've shown you earlier. What should be our expected output? It should be 2176511 -1. So it is 2176511 -1. So this particular test case will pass all the test cases that will be given to you. But one base case we forgot, that is if our n is double equivalent to 0, we will simply return null, because here in the question we were given this noting statement, return null if array is null. Okay, so I hope this particular thing is clear. But again I am telling you, do modify these return types as per your actual code. Do not just blindly copy this code, because once this return type changes, so this return statements also changes. Okay, and all there are different things that change too. So you will have to make those amends as per your question, as per your parameters that is given. So I hope now this thing is clear to you.